liftoff.
Over 50 years ago, the Apollo 8 mission launched to the moon in December of 1968. As part of this mission, 3 astronauts were able to capture an iconic image of the Earth rising over the moon known as Earthrise.
Okay, we're rolling around to a good view of the Earth.
This image inspired a generation of environmental activism, starting with Earth Day and decades of environmental activism since. The NASA Goddard Space Flight Center's Earth Science Division is the largest collection of Earth scientists on the planet. And our job is to be the nation's trusted source of comprehensive environmental information about the current state and the future of the Earth. We build, design, launch, and operate scientific missions, including satellites, airborne campaigns on aircraft, as well as ground campaigns to understand how the Earth works and how to predict how the Earth will change in the future.
Goddard developed 2 space-based LiDARs that have launched in the past year. Those being JEDI, which is used to measure the vegetation, structure of the Earth, and ICET-2, which measures, among other things, vegetation, atmosphere, ocean, and changes in the ice cover. With ICET-2, we're just starting to see the first year of data. So what we've seen is the thickness of the ice in the Arctic change over the course of the year. So we've seen it at its minimum, and we saw the ice grow to its maximum extent in March and maximum thickness. What we've seen too is that thickness, it's a lot less than it was in prior decades. So it's about half as thick as it was, say, in the 80s. So we've seen a substantial change in the ice. We've also started measuring ice in the summer with ICET-2 and looking to can we see how thick that ice is. It's a procedure to be able to do that, and this is brand new data that we're just first seeing with ICET-2.
From our vantage point from space, we have a global perspective on the role of fires in the Earth system. We see landscape where fires are increasing, especially in places where there's plenty of fuel to burn. Warmer and drier climate means those fires can grow faster, get larger, and blow their smoke further downwind, impacting communities not just in the locations where fires burn, but people thousands of miles away. NASA has more than 20 satellites on orbit right now, and each of them help us tell the part of the story about how fire changes the Earth system. We are the first to detect fires burning in remote locations with satellites that observe the location and the intensity of fires. We're also then tracking the smoke and the way the smoke from fires blows to impact not just local communities, but people that could live thousands of miles away. Fires in California, for example, in 2017, sent their smoke as far east as New England. Those trace gases and the aerosols that fires release then change our entire planet. And so at NASA, scientists like myself are responsible for not just finding those fires, but tracking the impacts they have on ecosystems and the consequences of those fires in our atmosphere.
NASA has been studying ozone from space for about 40 years now. We have nearly daily global measurements of ozone since 1979. Science is showing us that the Montreal Protocol is an effective treaty and it's working as intended, and I think that's fantastic news for all of us on the whole planet. We learned that if you look at the HCl, hydrochloric acid measurements, during certain conditions inside the ozone hole, and then you track those conditions each year, you can make a measurement of whether or not the chlorine is going down. And it turns out that as the chlorine goes down, we're seeing the amount of ozone depletion going down right along with it. So the two are tracking together. And that gives us confidence that this treaty is successful and it's working as intended.
The ocean is absolutely immense, and it's very difficult to be all places at all times. This is where satellites come in. There is a fleet of Earth-observing satellites hosted by NASA that view the global ocean every 2 days. The PACE mission is NASA's Plankton Aerosol Cloud Ocean Ecosystem mission, scheduled for launch in December of 2022. It is NASA's next big investment in the combined study of the oceans and the atmospheres. From the oceans, it's designed to improve our ability to discriminate and identify phytoplankton community structure, in particular, their evolution in time and space.
Satellites
give us about 6 million observations of weather every 6 hours. So that's a whole lot of data. One of the things at NASA that we do is try to do a good job of merging all of that data with a model field. That's the starting point of a weather forecast, and that helps us improve the way that we can predict weather, that improves the way that we get weather forecasts on our phone, and improves our lives a little bit every day. NASA plays a really critical role in that because we understand satellites probably as well as anyone in the world. And so we can really pioneer and get new types of data into those weather forecasts and make sure that that helps us improve forecasts for everyone going forward.
Being at Goddard is absolutely incredible. It's one of the greatest collection of earth scientists in the world, and so the access we have to each other is just, in my mind, unparalleled.
There are so many really smart people that have expertise in so many different areas of atmospheric chemistry, dynamics, in measurements, in modeling.
It's a fast-moving group of people, but it's always changing, and it's a whole lot of fun to be a part of all that energy.
NASA's Artemis mission is an opportunity to look back at Earth and regain that sense of awe and wonder that we had with the Earthrise photo that inspired our environmental movement.